Hello friends, welcome back. Hearty welcome to you. We are solving problems related to modulus of a variable. So in this session, we will look at this example. We have been given that modulus of x minus 2 minus 1 divided by modulus of x minus 2 minus 2 less than or equal to 0. We have to find out the solution set. To start with, let us see how x value can be. I have two cases. One, maybe three cases: x less than or equal to 2, x equal to 2, x greater than 2. So with these three cases I can identify all the values of x because the number line is now divided into three parts. So let's go ahead and do that. We'll draw a number line and 2 is the point. So now we will take each interval, one time x less than 2, one time x greater than 2, and also maybe x equal to 2. We will see what will be the solution set based on how the numerator and denominator will change. Now first let's take this interval x less than 2. What will happen in such case? Let's go ahead and write that. We know that here x less than 2, that means x minus 2 is less than 0. By definition, then mod of x minus 2 will become minus of x minus 2. So can I go ahead and now write down given function as minus of x minus 2 minus 1 divided by minus of x minus 2 minus 2 less than or equal to 0, or can I say minus x plus 2 minus 1 divided by minus x plus 2 minus 2 less than or equal to 0, or can I simplify and say minus x plus 1 divided by minus x less than or equal to 0, which is nothing but x minus 1 by x less than or equal to 0, because I can take minus common here. Minus of x minus 1, minus minus will cancel. I have x minus 1 by x less than or equal to 0. So this is how the f of x became in the interval when it is less than 2. Now let us check for when equal to 2 what happens. Equal to 2, this will be 0, 2 minus 2 0, 0 minus 1, 0 minus 2, 1 by 2, 0.5 is less than or equal to 0? No. So x equal to 2 is not a solution at all. So now we have to go ahead and solve this by using wavy curve method. Before going that, we want to go to this interval 2 to infinity and see how the function will become taking x minus 2 greater than 0. So we'll try to finish that, then we will go to the second part. So let me change the color for this. Okay. Now in this interval we know x is greater than 2, that means x minus 2 is greater than 0, that means mod of x minus 2 is equal to x minus 2. That's the definition of modulus, or absolute value. Basically modulus means it gives always positive. If it's greater than 0, it gives value as it is. So x is greater than 0, mod x is x. Now when mod of x minus 2 is x minus 2, this will become as it is x minus 2 minus 1 divided by x minus 2 minus 2 less than or equal to 0. So can I say x minus 3 divided by x minus 4 less than or equal to 0? Now these are the two functions on which I need to work on now. These are the two functions I have to find out the solution. This is for the interval minus infinity to 2, and this is for the interval 2 to infinity. Now let's go ahead and try to plot how the solution set will be for this. So we'll go ahead and try to plot the graphs. For these two solutions will be adding up afterwards. So I will draw the number line for the first case and the number line for the second case. Now we have to do wavy curve method. So this is minus infinity to infinity, minus infinity to infinity. In the first case, the critical points are 0 and 1. So I'll plot that 0, 1 here. In this case, we have critical points are 3, 4. How will we do that? If you remember, we'll first go ahead and x minus 1 divided by x less than or equal to 0. So let us take a value. Suppose let us say 2. 2 if I consider here, 2 minus 1 is 1, 1 by 2, 0.5. 0.5 is less than or equal to 0? No, it is wrong. So I can say this interval is wrong. Then I know automatically by wavy curve method this interval is right for me and this interval is wrong. Or can I say this interval is plus, this interval is minus, and this interval is again plus. What we are interested in is less than or equal to 0. That's why that interval is what I am interested in now. So how that interval solution will be, I'll write down. Can I have 0? If I have 0, it will not be defined. So 0 is not considered, but 1 is considered because we have equal to symbol there. So the solutions first case scenario is 0 to 1. 0 not included and 1 is included. Let's go to the now other case. Other case is x minus 3 divided by x minus 4 less than or equal to 0. Now in this case, since I don't have any x in the denominator, I can go for 0 to my whole front back. Put 0 there, somewhere here, minus infinity to 3. 0 minus 3 minus 3, 0 minus 4 minus 4. Minus 3 by minus 4 is 3 by 4. 3 by 4 is less than or equal to 0? No. 3 by 4 is greater than or equal to 0. That means this is positive. If this is positive, then this is negative. This is positive. What we want is less than or equal to 0. So we want this, we don't want this, we don't want this. What we want is between 3 and 4. Since I can have equal to 0, I will go with the 3 and I will not take 4. So that will be that square bracket and this will be curvy one because the boundary is not included here, because if I take 4, automatically the function is not defined. So what is the solution of this whole thing now? It will come down to, let's put it in another color so that we can write down. So from these two scenarios, one scenario we have done for x is less than 2, another scenario we have done for x greater than 2. These two I have to club them together now. So the solution will be 0 to 1 union, then 3 included and 4 excluded. So this is the solution for this particular example. We will see more this type of examples in the coming sessions. This is one example which I thought of sharing with you. We'll be doing more problems. So I'll catch you in the next session. Till then, keep smiling and sharing. Bye for now.